So I'm Jason Perkins. I'm the head of data and analytics architecture at BT. I think everyone knows BT, don't you? British Telecom. We also own EE these days. I don't know if you're aware of that as well. We bought them about just under 2 years ago. So, UK's largest fixed and mobile content provider. So who am I? So I'm an architect by trade, a technologist, but an architect. I've been an architect for about 15 years now. I came into BT in 1990, only for the summer. What's my story? Well, I screwed up my A-levels, that's the truth of it. I was only there for the summer, and then I saw my A-level results and realised I'd have to stay a bit longer. And as it turned out, it was quite fortunate for me because I did my, went up at the HNC route and then went and did my degree through BT. So I came out with no debt at all, which was pretty cool, but I didn't have much fun. You have to work 4 days a week and only do your university on the one other day. But it's been a really interesting journey. Started off really in data about 15 years ago, and that's where I made a strategic bet with my career, really, that I thought data was going to take off. You're probably all too young for the Bob Hoskins, It's Good to Talk. Yeah, there we are. Someone remembers. Yeah, so that was our big marketing campaign in the late 90s. Data, was used in those days to do marketing. And we had a company called Carter Marketing that came over from the States, and they came up with this great idea about how we were going to market ourselves. And it was called Friends and Family. And it was basically we offered discounts to people if you were ringing your friends and family. And the marketing was quite easy in those days. If your number of minutes went up, usually the customer was having a good experience, and we made more money. And those were two good things. So it was all about trying to increase minutes. That was what the name of the game was back in those days. But data has evolved a lot since then. It's a lot more sophisticated these days, what we want to do with our data. People, we'll talk a bit more about that later, but there's a much richer set of services you offer. You've got your fixed, you've got your mobile, you've got your content. So you're having to think about that from an architectural perspective, and you've got a lot more data you have to deal with these days. It was quite hard dealing with 1 billion phone records a day, but now you have to worry about what click data they're doing, what else, what mobile data. Mobile data is growing 7 times 7 growth by 2020, and that's how your architecture needs to be able to deal with that, it needs to be able to scale. And that's the real challenge of enterprise architecture at BT, at the large data companies, is how it's easy building something. How do you make it scale? How do you make it reliable? How do you make it work all the time? Because everyone, what's the average, 10 years ago, what was the user response time? What would a user expect as a response time if they clicked on something? It was usually around 5 to 8 seconds people were willing to wait. What do you think the wait time is today?
2 seconds.
Yeah, 2 seconds. 2 seconds. And what happens if you don't get in 2 seconds? You either go somewhere else or hit and refresh and trashing the system even harder, which is So that's where the world's changing really. Through BT, one of the great things about this isn't an advert for BT, but it's about my journey. I've had an opportunity to work in different areas. So I started off in procurement. They had 8086, if anyone probably doesn't remember those, but those are the first computers. And the reason I got into computing was purely because I was a chemistry major. I said, that looks interesting, and everyone else thought they were like typewriters with TV screens. That was this is the pre-dawn of the PC age. And I got into that and built a procurement MIS system, and then moved on into actually our IT software engineering centre in Cardiff, which houses today about 300 people. From there I went into BT Health, and we built the NHS. This is NHS England. Don't confuse them with NHS Wales. NHS Wales, a different, it's evolved, but this was the world's largest data warehouse for health in the world. So, and the real, interesting stuff there, payment by results, moving towards tariffs of £34 billion we had to process through there to understand. So you got paid for the work you did rather than just getting, dividing it across the number of patients. You actually got paid for the work you did, so we could actually work out what work you're actually doing. So if you had a hip operation, you got paid a certain amount of money. We also looked at stuff like readmissions. So readmission sounds quite easy to do. How do you do that? If someone gets readmitted, then it's the hospital's fault, surely, isn't it? In 28 days, that was the rule. 28 days, you come back into hospital, it must be the hospital's fault, isn't it? But when we looked at the data, what you could see was if someone had an eye operation, they had a much higher chance of them falling down the stairs. And often, if you had an eye operation, you'd actually come back in with a broken leg. It was one of the popular things to happen, or a broken arm. You also might end up with an eye infection, which probably was, maybe you could say there's someone else's fault for that. But so really interesting, how you're changing. But also, what we try to do is league tables around hospitals, because if you're going to, the whole point of was pushing choice. Because how do you get, when services are free in the NHS, how do you drive better standards? And part of the idea was choice. So how do we offer choice in terms of metrics? So one idea was, you'll show how well your doctor does, your surgeon does, and you'll choose them based on, do you want to go to this one who has a really great success rate, or do you want to go to this one which maybe the success rate isn't quite so good? And this will drive you to think, actually, if the guy I'm going into the scalpel, I want to go with the one who's got the best. But then what you found was often the ones who had the best record were not taking on any of the hard cases. You're thinking, I see. This is the striker that's playing the equivalent of, was it the Burnleys and the Watfords? And he never plays the Manchester Uniteds or the Arsenal, so he always looks like he's scoring lots of goals. So, all right, then maybe given I've got more complicated surgery, I need to go for a different sort. So you have to think about how you weigh those sort of things into your metrics. Then went on from there with BT, went into the open census. So census 2012, how do we make that available to everyone? So building a large open platform so people could make that data available. Again, challenge of scale, thousands of users, millions of data sets. What we wanted was a schemaless or a generic schema that allows us to open up that data to everyone. And then came back into BT, and now I'm heading up data analytics. So just an idea of the scale of BT, we've got 27 petabytes of data. What do you think? 27 petabytes. What do you think what could you hold in 27 petabytes?
You could hold about 12 humans.
Well, the DNA for every person on this planet. It's about 2-3 gig. The DNA.
Okay.
The memories you can't. The memories are about 1,000 times, isn't it? Synapses and all the rest of it. That's much bigger storage.
I want to explain my thinking. My thinking is that they say a human brain is worth, I think, 2 petabytes.
Yeah, there's various calculations, and that's usually about the synapses rather than DNAs. So the born versus made, you actually create a lot more memories. That requires a lot more storage. But the actual DNA is actually a lot more efficient in theory.
Right.
But yeah, so the key thing is you can store a lot of stuff in 27 petabytes. And my challenge in the analytics part of my role is how do I build an architecture that enables people to use that data to make the best decision they can make. That is the challenge. That's the architectural challenge that we'll cover in some of this talk. So BT, as you can see, you've got the arm's length part of BT, OpenReach, which is ear gap from the rest of BT. Consumer, which is where our TV and fixed, EE, which is our mobile arm. Public business and public sector. This is all about delivering businesses to business, which tends to be an Ethernet product, but also a large, more complex. So you think, what was it? NatWest? What was the old stat used to say? Something like we've got hundreds of sites around. You're managing sites around those. Global services. So we're in 185 countries. So again, we're offering services usually to major companies, so Mars, your Glaxo, and offering services across there. It's all about interconnectivity, connecting people up. And then wholesale and ventures, wholesale providing the core network for BT. So very different challenges in terms of architecture and what you're trying to do for those different companies. They tend to be, ones. These tend to be volume. These tend to be enterprise. This tends to be international. This is a regulated part, which brings in other different challenges. And then you've got ventures. So we also have about 50 venture companies. So Redcare that does the alarms, through to BT Fleet. We run the biggest fleet arm in the UK because through our engineers, but now because we've got all those vans. But also we supply fleet services for a bunch of other companies. For example, the AA, which is quite an interesting one.
Charlie is coming to talk about this.
Shani does. So 25 billion pounds roughly. That's the amount of money we're talking about per annum. We're turning over. So when we talk about architecture, it's always important to think about what architecture you're delivering for the business. You always need to be thinking about what is the business purpose you're trying to actually deliver here. Because you can't deliver technology in isolation. It's very easy to get seduced by the shiny new tool or the shiny new, but you need to deliver something for the business. So this is BT's purpose. These are obviously aligned to some of our customer-facing units. There's the people side here, which is very easy to forget about as well. So you want to have, the best place to work is all about, you want to produce architecture that delivers superb experiences, not just for your customers, which is really important, but also for your employees. You don't want to deliver architecture which waits 5 seconds. You have to click on it 73 times to actually book your annual leave. Or like we bought a COTS package. You heard of custom off-the-shelf packages. So you're buying a package, and our annual leave system actually counted the annual leave in minutes. It was international, so it doesn't matter where you went in the world. The day was the same amount of, and you could actually, all you have to work out, I always have my amount of minutes I had of leave I could book. It's not very user-friendly though, is it, And these are things you have to think about. And also our HR system, when someone left BT, it sent them an email saying you've been terminated. Which also didn't sort of deliver that best place in work. It was an American company, that's the way they sort of talk to people if you heard Donald Trump. But anyway, that's, so you need to think about those. So creating a great experience is really, really important. And that's a major challenge these days. So not just from non-functionals, but also from user experience design, which is really human-centered design, increasingly important skill set you need to think about. Investing for growth. So looking at how we deliver services that's truly transformational. So now we'll talk about, in terms of data, how do we use that to personalize our products, to personalize the experience we give our customers, and then transform our costs. So stuff like open source presents some great opportunity. It reduces dramatically our cost base. We spend a lot of money with commercial. Sometimes that's for good reasons, other times less so. So where can we get the benefits of commercial software? Where can we get the benefits of open source software? Important things to consider. So let's talk a bit about BT's enterprise architecture. This is a high-level view of BT's architecture. Now, BT, in terms of the number of applications, we know how many applications we've got. It's roughly about 2,000. Okay. So I'll talk you through some of this. So at the edge, we've got customer premise equipment. So what would that be? An example be for BT? Do you think what would be your customer side applications?
Phones, like routers and houses.
Would be. I mean, so in a software-defined world, usually when we think of apps, so routers. So the hub is a good example. Increasingly they're software-driven, aren't they? The hub's got a bunch of software on there that we have to, and we also maintain it, and we bang updates out to it these days.
Your website?
Website tends to be more in the collaboration space. So it is customer facing, you're right, but usually customer premise is actually on the customer side of the, so the phone stuff that we control is usually so the set-top box, the hub are probably good examples. Sorry, is that?
Yeah, I was going to say, like, you got loads of web stuff you got to do with the set-top box, with iPlayer and all that.
So we're updating those offline over the network these days. So so all the apps around that sort of stuff that's very customer on the customer side. How do you monitor? How do you maintain it? That's managed by a set teams. Enterprises have their own. So you have a business hub, and it tends to be a different set of equipment. Often you're thinking about different things. So you're often managing a lot more complex estate than a single, but it's a volume game. So in consumer, we'll be managing 15 million hubs. In the business side, we might be managing many servers for a single company, a very large company. Then we've got the collaboration end, the digital. This is your digital footprints. This will be your websites, your customer and product. So that'll be your CRM system, if you will. So capturing the customer's details, understanding what products and what assets they've got. So they got have they got broadband? Have they got ultra fast broadband? Have they got what sort of mobile service they've got? You've got your billing and your payments. Well, that's digital bills these days. You actually got paid. Then you've got your what we call this is my area over here. So anyway, so we call this the business services. So we're trying to simplify this because 2,000 apps is too much to get your head around, isn't it? So how do you logically start segmenting this into a state that you can actually describe to people? So that's a key thing about architecture. You need to be able to describe it to people. You need to be able to describe it to your stakeholders in some way that they can make sense of it. What is that doing for me? So each of these will have a service description behind them. So this is your business service layer. This is all your business, your stuff you're exposing to your customer. These are all services you offer, usually around managing your business. Then you've got your operational layer, which is all about managing your network. So how are you doing, for example, assuring that actually your network, how are you doing your enterprise workforce management? So how to make sure engineers are out there and I'm booking them in when they've got faults and stuff like that. Fulfillment and service delivery. So I've ordered something, I want to get that actually fulfilled now. I want to get that actual new broadband line installed in someone's house. Capacity affirmation, test and diagnostics. So how every night you might be running millions of tests on your network. Because what we want to move away from reactive management. So, so a classic example is smart cities. How do you think people do lighting today? They manage the lighting on the roads in the cities. It's not very high tech, I'll give you a clue.
Turn them on at a certain time.
Someone drives around and ticks. Yep, that's working. That's working. Smart lighting is basically just the idea you put a sensor in there and it comes up on a dashboard saying, "No, look, that's not working anymore." Obviously, these are a lot more sophisticated use cases. You can decide when you're going to switch it on. Much more sophisticated today. Usually, it's using light, follow the sun type models. But you could probably say, actually, if there's no traffic on this road, why have I got lighting on here? Why don't I switch it on just as traffic is coming towards that lighting? I could get a lot more efficient. Although in the current austerity, the simple way was let's turn off all the lights. Why do people need light? That might be another. That's another model you could follow. You've got your infrastructure then. And infrastructure is more than just your boxes, but now covers everything from end user technology. So what technology you provide? So my laptop, through to your cloud services, through to your data centers. You've got data centers for your IT. You also got data centers for your network. So we've got the core network, which is running the mobile network or the fixed network. Then we've got the service execution domain. That's where our TV sits. So that's another bunch of services over here, which tend to use a BSS, but generally they've got their own OSS. IoT fits in here as well today. That's a separate stack. The reason why do you think that might be a separate stack? Why is IoT just not a standard IT stack?
Still does, new technology.
It's new technology, it's right, but you're just going to order IoT, aren't you? You order mobile, you order TV, you order fixed products.
Everything. So it's going to be premise equipment. You're going to want loads of back-end servers for the communications.
Yeah, it's ubiquitous. It's a bunch of stuff, isn't it? We've got a small number of products in theory. My product managers will tell me I've got loads of products I've got to manage. I've got hundreds. But in theory, IoT could be millions, couldn't it? So you've got a different set of scale there to worry about at the moment. You've got even the networks. It's not a single network. It's all about mesh and all a bunch of other stuff. So today it's in its own incubation phase over here. Now, for me, it's often just three. There's obviously security. We've got end user technology in there, but for me, there's three big layers. There's the business services. There's the operational services around managing the network for us, and then there's the data services. The data services is really about 10 years ago, it was about reactive. How's my engineers doing? How's my call center monitoring? How's my network monitoring? That's what we were doing over here. Today it's much more proactive. So we're talking about software-defined networks, network virtualization. So everything that's hardware is now becoming software. So what that's allowing us to do, we can capture a lot more data. and we can use that then to do stuff much more intelligent. So we can have a self-healing network. We can have a self-optimizing network. These are all sort of changing the game. I mean, revenue assurance. Revenue assurance is the idea that bill no service or service no bill. It's quite easy. You're given service and you're not getting paid. How much, so over the last 5 years, how much money do you think we've found that where we were actually giving service but not getting paid?
Millions.
Pardon?
6 million.
Yeah, not bad. £1 billion. £1 billion where we were giving service but we weren't actually getting paid. Now, my kids like to look down the back of the sofa. We've never found £1 billion. Never found £100. But £1 billion. So that's really important for us. Is having those checks and balances to make sure. So one classic one was, which we fixed now, some other providers may not have, was data SIMs. You understand SIMs? You get data devices. So you might have like an iPad, which you're not really using for calls. You're just using it for data. You have a data SIM in there. And the idea was, well, that data, you only ever use data on that device. But let's call them enterprising people, thought, I'll take the SIM out of there and put it in a phone and see if I can make international calls. And people didn't consider that. And actually what it meant was you made international calls, but you never got charged because no one actually thought of setting up a phone tariff on that device. But we've obviously stopped that now, so you can't do that, just so you know. But all these sort of interesting sort of use cases around that. And there's the IT view, if you break it down. So tend to think of this as blended. This is managing your network. This is your business layers. So all about transactions, transactional management, so OLTP, online transactional processing. Have you heard of that sort of abbreviation? So I want to order. So typically, when we talk about different types of transactions, where do you think? Do you think it's in this area? This area? Where would you say our growth is in our data when I talk about ×7 type growth? Yeah, this is typically, it's event data, is typically what we're processing down here, and that's where all our growth is. So usage. So how are people using the network? How are people using their mobile phones? How are people using set-top boxes? How are people using hubs? That stuff that's, people, you can't give them enough data allowance, especially, and here you can understand, where do I want to make investment decisions versus my mobile versus my fixed network? Today, what do you think people use more of, fixed or mobile? Sorry, I didn't. Fixed, hands up. One. Mobile. So give me an idea. What's your monthly mobile? Most of you are on limited. Is it 4, 8 gig, 20 gig?
24.
As much as you want?
3 gig.
3. Okay. How much? What's that? One film?
Enough music.
Yeah, enough music. So typically, what we find, 95 to 98% fixed. That's how much people are hitting. Vast majority, or a lot of your traffic, vastly outweighed into the fixed network. If you've got a Netflix account, who's on Netflix? Not that I'm a big promoter of them. Much BT Sport is the one you should be on, or BT TV. But Netflix, massive growth. If you look at their numbers, I'm a Netflix customer. You watch one series, binge watch it. That's much bigger usage than your mobile network, your mobile usage all month, isn't it? You watch, was it House of Cards? What's that one? Altered Carbon or whatever it was. I was watching. So, and that's what you can really do with data warehousing, and that's the big growth area for us. And that's been one of the big challenges for us: is how do we get the nuggets out of that event data? What was really interesting in there? So this is where you start to think about how do you compartmentalize, how do you decompose your architecture. Now these are sort of Phil Radley, who works for me. He's our chief data architect. He likes this sort of 3D sort of effect. I'm not a big fan of it, but it's quite good in terms of breaking down what our main architecture areas are. But now we're going to talk about transformation. So Rachel Hyam's the MD for IT, and she's driving what's called the Da Vinci program. And part of that is we're trying to transform our enterprise architecture. We're trying to transform the whole organisation, but enterprise architecture is part of that journey. And we're talking, there's lots of different ways of looking at enterprise architecture. There's 4+1, there's TOGAF, there's Zachman, lots of different ways of looking at it. But one of the ways we're looking at it is these different lenses. So we're looking at a process view. So we'll talk a bit more about that in a sec, but broadly, it's talking about how you take it through from a business strategy through to an IT strategy, through to a data strategy. So, which one do you teach here? Is it PPT, people, process, technology, or do you do POTI, people, organisation, technology, information?
Neither of them.
No? They don't do people or process? Uh-oh. So when you're thinking about architecture, you usually need to think about those different lenses. So technology is a really important lens, but you need the people. I always say my systems work beautifully as long as I don't have any people on them. It's people. One of my friends is a bus driver. He also said the bus is always on time as long as I've got no passengers. But you need the people. The people are really important. But then you also need the processes. So when you think about processes, how am I going to integrate into this process? Often when you're building an enterprise architecture, you're talking about, so you're linking into some process, whether it's a lead to cash process. So you need a lead to cash. That's quite a common one. How do I take from having someone who's interested in my product? What's the process they go through to actually getting paid for them delivering a service? You've got to think through what are all the different steps through my architecture, through my business services, through my operational services, through my decisioning services to actually deliver that end-to-end journey. That's your process. You've got trouble to resolve. So someone rings up saying, I've got a problem. What's your process? Where do you fit in? What are all those process steps in there? Your people processes. In America, they like to call it, UK we call it hire to retire. What do the Americans call it? That's the one. So, what are your processes? How do you go from recruiting an individual all the way through to seeing them into retirement, or the American alternative? So you've got to think about process, really important. We've gone big into services. What's your idea around it? What is a service? Yeah, it's something you provide for other people. It's not something you do, it's something you provide. So it's actually how they see it. What do I get out of this? And what's driving that for us is the cloud transformation. What we're seeing is the Amazons, the Azures, the BT Computes, the Google Clouds. People are starting to consume these services differently these days. We're moving away from use cases and bespoke delivery, procuring things more and buying services. I want to just deliver these services, and then I'll configure, customize on top of that. Okay. So if you think from an analytics viewpoint, I want a decisioning service. I want an ingestion service. I want a reporting service. So I want, if I'm delivering a new product, I want to do some reporting on that. I want to ingest some new data. I want to integrate that data. I then want to deliver some reports on top of that. And maybe I want some intelligence. So I want some modeling, analytical modeling. I want to predict who's going to stay with me and who's going to be an early leaver. So a classic problem you have if you launch a new product is early leavers or failure to launch or all those sort of analogies. So, if someone doesn't use your product in the first 90 days, what do you reckon the chances are they're going to use it in the next 90? Yeah, it's very slim. So you want to make sure they're using that product really quickly. People like Netflix are very good at that, always making recommendations. Have a look at this. Amazon's very good, As soon as you hit that button and you buy, what comes next?
Try this.
The email saying, well done, you've bought this, share this with all your friends, and then what comes after that? The next email saying, it's out on the door. It's trying to create that interactivity with your customers, So all that sort of, you've got the timeline view. So one of the challenges of architecture is tactical versus strategic, taking the longer term view, Are you building things to last, or are you building them to change? One of the great things I like about being an architect is, I'm building the Christopher Wren. You're building the great architecture that's going to be around long after. I might work on a project for 2-3 years, but it'll be around for 10 years after I'm retired. We still got mainframes that were when were they done, in the 80s? People don't even remember how they were built. It's like it's like when you see those cave paintings, you think, who the hell did that? What the hell does that mean? But that's it's your chance to lay down some architecture. So you're building things to last. You're building them to change. So those are the things you're thinking about. When I'm procuring a new system, I'm thinking, do I extend something I've already got, or do I build something that's brand new? And if I build it brand new, what's added to my cost base? How will I maintain it? How will I manage it going forward? These are all things you need to think about in terms of your time, your horizon. And then your strategic view. So, sorry.
When you're looking to build something and say you want it to last for 10 years, so in 10 years' time the technology is going to be completely different. What are the things that you key things that you would look at when
So good question. So things we'll be thinking about is portability. How easy is it to port that from? So if you're using some general purpose, so SQL is a great language. It's ubiquitous. It's used everywhere. And I've got stuff that was built 10 years ago on 8i, Oracle 8i, Oracle. It runs perfectly well today on 12c. So portability is really important. That I can actually port this and I can move with it. If you take my CDs, I've still got. Does anyone remember LPs? LPs don't run on most CDs. It's actually quite hard to take that music when you've got it in that format and play it on something today. That's the sort of, or video cassettes, DVDs even. Try and find something that plays a DVD these days. It's actually quite hard because everyone's moving to more software-driven ways of playing things. So you're looking at formats that offer portability. You can play them on future devices. Digital helps to that extent, but some languages, if you look at Hadoop, we started our Hadoop journey 3 years ago in terms of enterprise, running that in the enterprise. MapReduce is 10 years old, but already virtually all of the developers, all the people who are building it, have now moved on to Spark. 10 years from now, it will not be around, is my view. Anything I've built in MapReduce, it'll be scarce. There'll be a massive scarcity around people who can actually maintain that stuff. So I don't want it on MapReduce. I want to abstract away from that. So there I might use tools to abstract, that actually do a 4GL will actually write the code and I'll be able to switch it. So abstraction is another important pattern that we're looking for. So, and also looking for, so you're looking for popular stuff that's got a good usage base behind it. So that's why SQL has been popular. It's been like the English language of computing. Java is very popular, obviously. That's it's got enough momentum behind it. COBOL in its day had enough, but there's still some people around who can do that. So those are really important considerations. And then you do this modelling. So this is looking at different forecasting. What will happen in the future? What are the risks? So trying to do the risk trade-off analysis. If I go with this provider, NoSQL. One of the challenges are how many NoSQL databases today? Do you think? It's in the 50s at the moment. There seems to be a new one there's a new animal every couple of weeks. There's no way the market can afford 57 or whatever it is NoSQL databases. They're going to merge and they're going to acquire each other. And more, the risk is you end up with the Betamax, which is pushing this sort of space. So linking it to the business goals is really important. So there's a big focus on how we link it to the business goals. Looking at speed, agility is really important. So we want agile architecture much more these days. So that's a really important consideration. How do we move quickly? For us, those different lobs, we want to provide common services across those lines of business because that reduces our cost base, gives us more agility. So I don't want to be delivering a different decisioning platform to each of those lobs. I don't want to deliver a different marketing cloud to those different lobs. I don't want to deliver a different content management system to each of those businesses. I want to deliver a common one because I can do that at a lot lower cost base and I can manage change a lot quicker. Enhancing agility. So that's really about stuff like microservices architecture. So making stuff easy to consume, delivering things behind APIs. So we can do strong APIs, which give us a lot more, so we can actually loosely couple things a lot better. So moving away from stacks, moving down to more microservices, that type of architecture. So So our services, so we're actually thinking about what services do architecture offer the business now. You know, we want to be a professional services company now as architects offering a service. You can buy those services. So we're thinking about business architecture, and that's really the main innovation I saw come out of TOGAF. Was it, you know, before that we were looking at IT architecture, looking at data architecture, looking at operational architecture, but really TOGAF's main differentiator was it really thought about what is business architecture, what are business capabilities, what are business services you're going to offer, and then trying to link them to IT. Yeah, that was really important. I'm going to, you know, focus on delivering IT strategy, which is, you know, that's the sort of we start thinking about what the sort of services and what the strategies going forward. Make some predictions. You've got these different number of range of options. So, you know, where are we going to be in 2020? That's the current work I'm working on. What's our data architecture look like in 2020? That's where you get a bit the futurologist. You let that sort of, you know, your blue sky thinking. What do you think the key thing around this is? When you're doing that blue sky thinking, come up with all those crazy ideas and then trying to lay that down. One is linking to the business. That's a good idea these days.
Managing the risk.
Managing the risk, yeah, that's really important. Managing the reports. Also getting the feedback loop. Actually, how much you're, you know, that blockchain thing you thought was going to be a real big thing and hasn't, you know. Was it a great success? So trying to get those feedback loops so you can actually see if you're investing in the right place. You know, you've got to make tactical bets around which NoSQL product you're going with. You know, how. So it's really important to have the feedback loops around that. BT has a large research arm as well. So a lot of that's in the network space. So looking at 4G, looking at ultra fast. We also do it around IT as well. So, you know, we're working out there in AI at the moment. So as part of, you know, data analytics, AI is part of our space, machine learning is part of our space, business intelligence, marketing, that's all part of the data analytics domain. How much do you know about those sort of domains? Have you done much on AI? Little bit. I mean, that's the number one hot trend. Yeah.
Sorry, no. Just said a little bit.
Yeah. So, well, AI is one of the, you know, that's probably the number one hot trend at the moment. That's what Gartner have said for 2018. Machine learning was last year. So those are all data technologies. So, I mean, at the moment you've got to manage the hype. You know, you've got the Gartner hype cycle.
How are you using AI and machine learning?
Depends what you describe as AI, doesn't it? You know, AI is a very broad set of technology. So you can think of Siri or Alexa. They're types of AI. For me,
We did a project on Alexa recently.
okay, good. So it's pretty cool kit though, isn't it? It's pretty, you know.
Yeah.
My mum thinks it's all in that little machine. You know, she thinks, God, how do they cram all that stuff into that little device? She's amazed by it. But you know, today they're pretty what we call weak AI, aren't they? You know, they can't really solve. You know, people are worried about them taking over your jobs, but today, you know, it gets confused over even the basic stuff. It sometimes gets confused if it thinks the TV's talking to it, for example, in my house. But this is a massive investment space. You know, Google, Amazon, Facebook. I was out in Silicon Valley last year. You know, if you go out to the East Coast, AI, machine learning was just massive over there. I mean, they're buying out companies of 20 people. You know, in Silicon Valley, when you buy a company, it's based on they usually, one of the KPIs they use is how much each employee was worth. 3-year-old companies with very few customers are being bought out. How much do you think per employee that company's is worth? Yeah, 20 million is the current going sort of rate. There's a war for talent, a big war for talent. So we're looking about how do we manage that technology innovation into our stack. So stuff like AI is really, you know, for me, machine learning is really the stuff that's largely going mainstream. AI is still a couple of years away, in my view, for any major scale capabilities. So machine learning, which is probably where more Alexas and your Siris and that sort of fit, is really about, so, you know, the sort of applications for us will be around, you know, the self-healing network, trying to automate, you know, so today we get loads and loads of alerts off the network, but we've got so many alerts, it's trying to work out what's noise and what's real. And that's where machine learning can help us, because today a human being cannot actually do that. What they do is, what do you think they do when they get loads and loads of alerts? Well, they switch them off. That's their usual pattern. It's like, there's just too many for them to deal with. So, and usually they go with gut feel and stuff like that. Yeah, I know that one's really bad. We better do something with that one. That will catch fire if we don't deal with that one. But most of them, this is too much noise. Where the machines can actually see can actually learn which ones are actually important and which ones are not that important. So then look at the transformation models. How do you take it from the current state to your future state? And that's the hardest part, to be honest. Understanding your current state, you do your landscaping, what have I got today? And you do your future state, which is your blue sky thinking, this is what it's going to be like in a perfect world. And you do models and scenarios where it's not like I haven't got enough money to do the perfect world. What's the not so perfect world? What's the reality of what money I can actually afford to do? And you've got those scenarios there. But then try and work out how you get from current to future state. That's the roadmap. That's the hard thing to do, and align that with the business priorities, what the business actually needs. That's a key capability. Then you get down into your lower level, from enterprise architecture down into your solution architecture. This is decomposing. So it's all about hierarchical architecture. So your enterprise architecture into your solution architecture. So this is what billing are going to do. This is what CRM are going to do. This is what revenue assurance are going to do. This is what fraud are going to do. So you start to decompose your architecture into different building blocks. Then you do some assurance. What do you think the assurance is when you're doing the decomposition? Typically, the most likely place to break in an architecture, what do you reckon? People, yeah, usually it's the handoffs. People on their own, the billing team will do a great job, the customer team will do a great job, but usually the handoffs, it'll all sort of work, but not quite as you planned it or thought it was going to. What the hell did they do that? Why did they assume I was going to get that? And that's it. So you're looking at assurance, and you have end-to-end architects making sure. And, that's all about the agile approach. We have scrums of scrums. You're trying to deliver and try and get early. So test early is a key, principle. Test-driven development also helps. So we're thinking about how we're going to assure this process up front. What are the things we're going to do to test it? And build it in bite-sized chunks. Those are key things. And then we've got our advice service. So people can come to us and say, so the business tend to come to us, they've seen a show, AI is going to take over the world. How can there's this magic box, this vendor's told me that all I got to do is tell it the answer and they'll tell me how to solve the world. That's the architecture where we say this is the real art of the possible. Could we get chatbots today that actually mean we don't need a call center? That'd be great, wouldn't it? But how intelligent is the chatbot? It's only as intelligent as the data you give it for a start. What's the real art of the possible there? Now, there's a trade-off there. Today it's all about augmented chatbots in reality. So it's a human and a chatbot. A chatbot, a very simple chatbot. CIO, so in BT we have a CIO team. They act as the glue, sometimes called the intelligent customer. So they're the people try and translate the customer's requirements into something we understand and help us. So they're the people who are working with us on the business architecture and the business strategy. So they're acting as the bridge to IT. That's what we're doing in architecture, and then this is the downstream people. Obviously, you're trying to work closely together. It's all about, you don't want architects being in ivory towers. I've done that before now. I produce these beautiful blueprints, and then I see what those bloody developers have built. But they misunderstood. They misunderstood my genius. And there we are. It's much better to work closely together. So that again, another part of the assurance step. And also I get a feedback loop. Actually, that was a crazy idea, Jason. That would never work. That building would have fallen down if we'd have built it. So those sort of feedback loops are important. And business is important. So let's very quickly go through an architecture sort of case study. So we'll talk about our analytics architecture now. So we talked about some of the challenges. Digitalization, mobility are really changing the whole experience in telecoms. It's remarkably different from what it was before. Everything's mobile now, even fixed. No one's actually willing to have a hard wire into their home device, so everyone wants to be on wireless. The days when people thought that wireless stuff could be hacked by a car outside your house, people don't have to worry about that anymore. Everyone wants to be. Is that true? No one wants to be on a fixed line, do they? You don't actually have whatever you want to be able to move around the house at the very least. Connected everything. My kids, we went to Cape Tribulation in Australia 2 years ago. They were waving around their mobiles. It was quite a sad thing to see a teenager with no connectivity. They threatened me with social services if I ever took them anywhere again that didn't have 4G or an ultra-fast broadband line. My kids will not go in a restaurant unless it's got wireless. That's I say I don't want to go to McDonald's. They say free wireless. I want a nice hotel over there that looks pretty cool, but no Wi-Fi. Anyway, that's all about me more than so data analytics. Data's becoming at the heart of everything. Everything's collecting data these days. That's what we're seeing. So that's where we've got this massive data growth. We can if you look at where we're digitizing on the home, on the vehicle, everything's getting digitized, and that's opening up huge opportunities if you're in the data space. Most of the 10 years ago. Most of the big companies were what were they? You can think of it 10, 20 years ago, what was a big company? What were the big companies of the world?
Blockbuster.
They weren't that big, but they were around, they were big on the videos. But you're thinking, usually your petroleum companies, stuff are actually producing stuff. Petroleum, your consumer packaged goods companies, they were really big. Even your telcos were quite big. But these days, who's the really big companies? Software, well, really data companies, aren't they? They make all their money through data. They might have a cool UI, but it's really the data that's making them all their money. So Google, your Facebooks, Uber, Airbnb, all these, what do we call them, unicorns? No, unicorns, £1 billion worth. So, and joining up our data, convergence is a massive thing for us as well. So what we mean by convergence is the old traditional boundaries are blurring. So we're having a mobile and a fixed, that's blurring. Software and hardware is blurring. Software's ending up everywhere. Our network providers used to provide just devices. Now it's commodity with stuff on top. What we want to do is provide the best decisions based on that, and make it more fact-driven. Try and get people away from guessing. So much of our, the old saying used to be in business was, you'd have all these layers just so you couldn't see the person who was tossing the coin at the end. How did they make that decision? You just couldn't see it. They were like, well, I don't know. Yeah, heads there is, that will go that way. Actually, the data tells you this day, there's crocodiles that way. Maybe you want to go that way. So when you think about architecture, you're not the only one who's done it before. There's always other sources out there. If you're in a telco, there's the TMF, which is the Telecom Management Forum. They produce all has to check. And what do you think the last one is?
People.
This one's actually maths. Math stats. That's the real difference with data science. Data science adds an extra bubble, really. This sort of stuff, if you're doing just software, you need to do these two anyway. This is classic. If you're doing digital, you need to be doing that. But this is really bringing in the maths. And that's what we're trying to build. So we're trying to build more data scientists because the amount of data we got, you can't see it in a pie chart, you can't see it in a bar chart. You need to find ways to find patterns in billions of rows. And that's where machines are really good. But it needs people to help those machines. They can't do it. AI can't do it by itself today. It can't tell you which. It can tell you they'll find a pattern, but it won't tell you if it's interesting or not. But it can learn if you keep teaching it. This is the stuff I'm really interested in. And this is where the data science, this is what this analytical modelers are. And we're trying to find ways to simplify that so we can give it to people who are math literate but don't have to have a PhD in statistics. Because that's the really clever people today. Well, we'll come on to that in a sec. We've got a continuum. And we've done, these are our users today. And part of my job is to grow the size of the triangle and the number of people in that triangle. I'm trying to push them down. So this is our user profiling. So we build personas. So you need to understand who you're building your stuff for. We'll talk about that in terms of business capability. So we've got our information consumers. These are people who Just tell me how I'm doing. Give me my dashboard. Tell me how my call centre is operating. I'm a manager. I want to know, all my people busy? Have I got loads of calls waiting for it? You know, have I got a big spike? Is there some problem I need to be dealing with? Or I'm running an engineering team. How are my engineers? Are all my installs going on time? Are my faults down? Am I on top of the faults? The analysts tend to be the tactical people, so they're like the manager asks them, "What the hell's happening? We've got a new product launch. We're not selling enough." Or why have we got so many faults at the moment? What's really happening? Why is this product not that? Why is this problem not that popular? Why is Swansea selling 3 times the amount that Cardiff is? So you're the person who's going off the analyst and trying to do the root cause analysis to try and understand what's really happened. And again, machines can help there. They can help give clues, and that's where the citizen data scientist comes in. And using tools to say, actually, have you seen actually that in Cardiff they seem to be selling a lot more of this because they've got a lot more, I don't know, wealthy people, or there's a better salesman in that area, you know, whatever the reasons are. So one classic example we found with where we're looking at a number of calls were spiking in the summer into our call centres. What we've done a great job is moving people onto digital bills. You know, we've got them away from paper bills to digital bills. Great success, cost us less money, people are digitally enabled. What do you think the challenge is with digital bills?
Old people.
Yes, they don't tend to open them. Because you've got to click on the bill, and then you should do a portal, I've got to sign in there, I've got my password again. So what the first thing they do is when they see their bank statement and see they're paying lots of money, they ring us up and say, what the hell's happened? And that costs us a lot more money than the paper bill if they ring us. So it actually costs us more money. So anyway, trying to get into that bill shock and understanding actually this customer's got bill shock, why don't we try to intercept it and actually speak to the customer rather than wait for them to ring us? These are all sort of things you can do as part of your analysis. Then you've got your experts. These are, you know, in BT we've got tens of these. You know, so Detlef Nook in Ipswich is one of our research data scientists. So he'll be working with MIT. He'll be working with some of the cool new companies in Silicon Valley around how do we make sense of, you know, how can we model our network digitally. So we don't have to build it, we can model it digitally and simulate things digitally and understand how it's best to optimize our network for congestion. Where do we put the billions of pounds worth of investment we put into the network every year? How do we optimize it to make sure we're putting it in the right place rather than an engineer saying, well, yeah, let's give more to London. They always like a fast network in London. Yeah, so those are all the interesting sort of things. But the citizen data scientists, so Jason Howell, one of my colleagues used to work for me, he runs a data science team in Cardiff doing our enterprise data science. They're mostly engineers who have skilled up in this sort of stuff. So they're not, they were software engineers who we've skilled up in that sort of space, trying to grow them. So that's apparently a test they do if you go to a data science. So how would you go about counting the number of fish in the North Sea? The North Sea? Yeah. How many? That's a lot of bread.
Just like see how many are in a certain area and then take it like from that, do a load of random picks in certain areas, however many are in there, create an average and work out.
Yeah, catch release a couple of times and build up a model and do it, yeah, scale out from there. That's typically how you do it. Some people say drain the ocean and count them individually. That's another one I've seen. But yeah, generally that's a good way, catch and release they call that. So it's how you simulate, how you do sampling, and then you model that out. But you know, that's part of the challenge of data science. I mean, that's data science. So then we think about our technology. So these are some of the technology we've got in the application space. And the key thing here is trying to segment them by user and by capability to make sure we're not duplicating. The key thing is not to have multiple tools in the same space. So be that campaign management, so we send out marketing lists. We don't want to have 2 tools in that space. We want common services. So this is where we're modeling the different capabilities against different user space and saying, how do we ensure that we've got a common service there for our users? You see, the days of one tool to rule them all is still some way ahead of us. So we're about 18 now, I think. All the way from specialist to common features. So statistical process control, some of the data mining tooling. And then we've got the other side of the house, which is gathering all the data. You know, how do we scale out? We've scaled out with self-service. We're giving all these cool tools to people so they can ask all their questions. But how do we get the data and make it available to them? What do you reckon? How am I doing for time? Am I hopelessly overrunning?
You're a bit overrunning.
Yeah, I thought. So the challenge here for us is that today in our data warehouses, we've got about 5% of our data. And to scale out the other 95%, I can't afford to have 20 times as many developers. So I've got to find ways to make two main patterns. One, get the machines to help us. So we'll look at ways of automating loads and automating understanding those loads. That's what the cataloging is. So rather than having human beings model that, can I get machines to model it and just get the humans act as a librarian, making sure, try and make sense of it. I need to look at ways of securing it. So I've got, again, I'm looking at tooling to do that. I can't have human beings setting up all those policies and rights. So I wanted to set up the big policies and then let the machine do some of the clever stuff for us. Preparation is basically the idea that I let people play and experiment. And experimentation, you'll see, is a big area now in IT, especially in data. So that's why they call it science. They don't, science is different from doing an agile sprint. It's probably worth being clear on that. It does, it's all about dealing with ambiguity, isn't it? That's what the difference with, even when we do a sprint, there's some ambiguity, but you're still running to quite a clear idea of where you're trying to go. Where when you're doing an experiment, it's that sort of a, eureka moment where you're looking to get, you're going out there and taking a hypothesis and trying to prove, actually, is it real? So think about how is science different? Those are some key sort of questions for us. And this is the idea that you go off, do an experiment, and if it's successful, we industrialize that. So we're doing roughly 50 experiments in parallel today in BT, but we want to be doing hundreds or thousands like Google are. This is the Netflix where they try all the different colours, all the different. If you look on Netflix, you see the different tiles, the pictures. They run loads of experiments saying which tiles picture actually gets the customers to actually click on them more often to use their stuff. If you notice Netflix, what's it, House of Cards? They've changed the picture recently of who was at the front of that one. I'm not sure why. But yeah, there's a different picture on there now. I think they're probably getting better click-through on that one than they did their previous one. This is our service architecture, to give you an idea of what it looks like. So we're trying to think of what the services we're going to deploy, and then offer that as a catalogue. So you can go off and just order those. That's the idea, like a marketplace. That's where IT is going. That's what we see. People will order services and then they'll customise or they'll configure those services. So it's the old 70-20-10. 10% customise, 20% configure, 70% you buy it off the shelf. That's the dream we're all working to. Because you can't scale this stuff out if you've got to build brand new CRM systems and all that. It's too hard, too long to move. We've done that. That's talked a bit about data experimentation, done transformation. Trying to organise all that's quite hard. In the data warehousing world, what you did is you have schema on read, schema on write. So you write the schema, integrate your data, and integrate it into a common data model. And that was really good because all your people who use it got a common model then, and you put all the work into sorting all your data out. And the theory behind that is because lots more people will read your data than the number of people who will write it. That's the idea. And because you're doing that for your really most important, your hottest data, a relatively small set, that scales. When you say, actually, I'm going to do that now for the other 95%, that doesn't scale. Because you're never sure if anyone's going to actually use all that other 95% of your data. You don't know you haven't got any usage patterns to model on. And it's just the scale of the challenge is massive. And IoT will make that even worse, where you've got ubiquitous loads of, today the average person's got like 3 devices. Predictions are they're going to have 30 by 2025, I think it is. When you've got 30 devices all generating lots of different data, how you organise that is a major challenge. So we talk about the Goldilocks Zone. So you've got ordered versus messy. And this is where, if you think about how you organise your rooms, if you're, it's all about that trade-off. Do I put the effort in to organise it so it makes it easier for me, or is it easier just to go in and just put it in randomly? So if I look at my socks, do I put 2 of them all together so I can easily find them, or do I just shuffle them in the drawer, and then when I go to get my socks, I then pick through them all to find out the 2 that match? Or do I just have them all the same colour so I don't have to worry about matching them? and go for the Facebook sort of. That's what he does, and he has all the same stuff, so he doesn't have to worry about it. But me, I like to have individual things, so I actually organise them up front because I think it's far more efficient. But in big data, that pattern doesn't really hold. So what we tend to do is hold data raw. That's the pattern generally, and only organise it when we get value from it. When we see repeated value, it's worth putting the effort in to organise it. If you're not going to use those socks, you may as well just throw them in the drawer, isn't it? And there's different technology at either end. This tends to be analytical relational technology. This tends to be the more file-based Hadoop type technology today. Also stuff like S3. I won't go through each of these, but basically it's a brute force versus a brainy approach. But if you organise your data, you can then think about how is it structured. You can optimise your querying to use that structure. If you haven't got structure, you're basically relying on parallel scale out, where you're going to smash it with just loads of compute and loads of I/O. Okay, so it's a divide and conquer problem over here typically. This tends to fit well where you've got a very simple schema, which like event data tends to be. This tends to work better when you've got a very complex schema. So you think the telco model I showed you, 10,000 data entities, quite complex. If you've got to do lots of joins, that scale out broad doesn't work. It doesn't like lots and lots of complex joins. You need to order your data. So again, technical architecture. This is the really cool technical stuff, really, that all the people are thinking about, especially when you try and do this at scale. And this is where we think about how we organise our data architecture. So then you have a data lake, data swamp. So data lakes are the sort of, the cool sort of thing 2 years ago in data warehousing. So the idea is a data lake. So data warehouse is your really prized transactional data, your orders, your customers, your inventory, your assets, all that sort of data. Your data lake is basically all your raw data from the applications. We've got 2,000 applications, so everyone gets a container. We want you to put your data in the data lake. So the main thing stopping us getting that access today is we haven't got access to the data. So we can get the data in the data lake. And the great thing about Hadoop is it's about 10 times the cost of, and then you can why you thought you needed a little bit of data, now you've got several petabytes of data. So data gravity is really important, and what we want to do is bring people to the data, not push the data this way. Cloud, we're in the early stages of working out what cloud architecture is. One of the challenges we see is what's called the clouder clouds. So what we're seeing is a lot of analytical, so your network companies or your customer experience companies or your sales companies, they're actually trying to grow their offering out of their vertical niches. So you go into like sales, and they've got sales applications, and they say, actually, give me all your data, and you can manage your sales, and you think, oh, that's all right. Well, I've just got my sales data in there. And then they say, actually, can you also send me all your fault data as well? Because my salesman wants to know about the faults before he talks to the customer. He wants to know if he's got an active fault. Okay, now I'm sending you my fault data. And they say, actually, can I have the network data as well? Because I want to know if he's using the network. Oh God, that's quite a lot of data I have to move into your cloud now. And the risk here is that you end up with a hairball. So generally what we're saying is we'll only support that where the data is sourced, the master source is that application. So sales data can be held in sales. We don't want to move the other data to sales. We want them to come and get the data out of the lake, just query it where it is. Those are the sort of patterns. So what we're really looking for is general purpose architecture, not vertical niches. Vertical niches means you end up moving data here, there, and everywhere, and that again is a hairball, and it costs you a fortune to maintain. Very hard to scale, very hard to make it work non-functionally. It's part of the challenge, how many moving parts have you got in your architecture? Where's data in motion? Where's data at rest? Fast data is obviously a big trend as well. We've got Kafka, Spark Streaming, Flink, which is the squirrel in Hadoop. That's all about a lot of streaming technology is really hot at the moment. So you're thinking about what do I do where I've got the data at rest? So I want to do offline analysis, or where do I need to make the decision in very short time so I can keep it in motion? So I want to make it before it actually hits the disk. Flink does some really cool stuff like time series data, which we've got a lot of. So that allows you, if you think of the Star Wars movies, the way they were made, They were made in the wrong order, weren't they? 4, 5, 6, then 1, 2, 3, now 7, 8, maybe 9 next one. Flink lets you reorder that on the fly. So it allows you to do a lot of that temporal sort of stuff, which a lot of stuff doesn't handle that well today. So some pretty cool features in there. I've gone through that pretty quickly. That was it. So think about data architecture. Data architecture sits in the analytics space. It's alongside your IT architecture. So you're thinking, the reason I brought this out is because it's really important to think how much you move your data, where you hold your data, how you use your data, and how do you make it available to people. You know, the key thing really from what I hope you take away from this is actually it's your data asset. What's the value you're getting out of your in analytics is actually the data. It's not the actual service itself. The actual value is actually coming out there is the curated data, the actual intelligence, the knowledge, the wisdom. That's the real value, and it's how you unlock that. And the way not to unlock it is to proliferate it everywhere. You know, so you need to think carefully about how, you know, that's what people like Facebook and Google are doing today. They're also not selling their data. They're usually selling the insight from the data. Because obviously if they sell the data, then everyone else can do it. So, anyway. It's a different sort of, so data is a key dimension of our architecture. That's something to think about. That's us. Any questions?
How much of a role does NoSQL play in your data architecture, and do you think it's going to get bigger or smaller in the future?
It is quite disruptive at the moment, so probably more on the operational data management side. So we're using it, so Mongo, Cassandra, the document databases are really popular at the moment, especially on the digital side of the house. So using those as a back end, so document tends to be much easier to model, and it seems to be very in vogue at the moment. So relational still tends to dominate. It's still the biggest part of the market. But I mean, the main challenge I see is I can't see all those vendors surviving. There's not a big enough market to, you know, relational databases, there were loads of them 10, 15 years ago, but now it's, you know, it's down to really Oracle, Microsoft, or IBM, or SAP. You know, those are the only big, you know, there's still some Postgres and MySQL, but the big ones, that they dominate, and I think NoSQL will go the same. But we are seeing quite a lot of growth around some of those new. So Martin Fowler talks about polyglot persistence, which is, you know, store your data in the right shape for the right use case. So graph and document are probably the two big areas I see growing. So if you look at the fans, the Facebook, Apple, Netflix, Google, they're using a lot of those new style storage technologies. So, you know, a lot of data, you know, master data management, we've tried to do that in relational for the last 10 years, but it far better fits a graph model than it does a relational model. Documents tend to be quite good for managing digital baskets and orders. It's a simple model. However, when you want to use data for analysis, schema, relational, dimensional, vault type methodologies tend to work better because you've got a lot better understanding how your data is organized, and that allows you to query it much more efficiently. So it's the right tool for the right job, but they are very popular at the moment. Certainly worth spending a bit of time playing around with them, seeing how they, what you can get, what they're good for and what they're not.
Last question, James, if any of these guys want to join PT and get involved in this exciting stuff,
Yeah, reach out. We do grad recruitment every year, so we have currently going through the current round. I think we're taking on 5 grads this year. Last year we took on 10.
that's
So
in
yeah,
Cardiff.
reach out. Yes, in Cardiff. So we got. I mean, you know, so I've worked a lot. So we've got Cardiff Software Engineering Centre. We've got Belfast, Glasgow, Adastral, which is Ipswich, and we've got Bangalore, which is in India. Plus, there's a couple other smaller internationals. We've got one in Dallas. You know, those. I mean, we're 13,000 IT people in BT, plus then partners, who takes us up to about 25,000. So, you know, we're the biggest IT employer in Wales. We're not just poles and holes. The people sometimes think we are. You know, we're the biggest data processor in Wales.
Would you go through your website for that?
Yeah, or reach out. Reach out to me. I can Shania. You know, we can also put you in touch. So it's btcareers.com, I think it is. But it's, make amazing things happen. You know, so I mean, you know, I've had the privilege with BT to work in the States, you know, work with some of the, work in Singapore, work in India. You can see that's positive or negative, whichever way, you know, but, you know, that is, it's working with lots of different people. That's what I really enjoy. And working, you know, the great thing about IT, wherever you work, to be honest, is the change. You know, it's changed so much over my career that, you know, it's not like if you, you know, some of my friends, they work in lorries or the post office, you know, that stuff that hasn't really dramatically changed, but our stuff continues to evolve massively. It's probably the most exciting time to be in IT at the moment, especially in data. You know, data is just madness at the moment. The sort of, you know, the reason I got my data science in Cardiff is if I let them go anywhere near London, all the banks are after them. You know, I try and keep them in the caves. You know, don't let them on LinkedIn. You know that. You know, it is that exciting a time at the moment.
Data jobs in the UK, there are 4 advertised vacancies for every qualified person.
Yeah,
That's how short, big and short.
that's
So
it.
make money doing things.
Data is, yeah, especially data science, AI is really, really hot. You know, as I mentioned, that's really, and you know, AI architecture is still evolving. You know, we're still into research. Research, all the people are trying to work out how this stuff works, and then all I got to do then is work how we do it at scale. You know, that's so TensorFlow and all that sort of stuff, GPUs. You know, all that crazy money that went into gaming is now how do we apply that to data? You know, so we're probably a good use case is, you know, well, cabinets. You know, we've got cabinets on the side of the road, which we put, we connect all your ultra fast broadband to. But you know, how do you think we actually capture on how full those cabinets are? Again, it's not that technical. It's not that sophisticated a technique.
You let it overheat.
No. We don't. Well, hopefully we don't know. That might happen, but that's not intentional.
Man on the clipboard.
Yeah, man on the clipboard again. He goes around half full, third full. This one's got a carrier bag wrapped around it because there was water leaking in, and the engineer was quite enterprising about how he fixed that when there was some flooding from the local river. But now what we're doing is, guy goes around, you know, got a camera, don't need to be technical, take pictures, model that, use GPUs, and we can actually tell how well it's organised, how full it is, and we just keep a database updated with all that. You know, and that's the new world. You know, and that's you know, that's quite a simple use case. We've got other ones we're trying around, you know, people and emotions and all that sort of stuff, which is far more sophisticated. But that's just a simple use case, which 5 years ago was probably not that different from when you did it in the Victorian times.
So,
Yeah.
These are final years,
Yeah.
graduate now, and you've had good software engineering experience, but not so much on things like AI, or at least not applied
Yeah.
on AI or with data science. So, I know one thing that you can do is go get a master's in data science, but if they would like to get involved and start their data science journey, there's obviously a huge amount of work out there.
Yeah.
Where should they start by themselves? Where would it be a good sort of place to see where they fit?
So, you know, the good thing these days is that, you know, using the web, you can get access to a lot of, you know, interesting courses. A lot of the big names provide free courses as well. So, you know, I know BT does a lot of hours to MIT and places like that, but they do charge. But Coursera are really good. You know, you can get access to some really cool stuff there for free. You know, John Hopkins and people like that make their stuff available. You can book yourself on a course and get a feel for that sort of those sort of spaces. Even so, a lot of the vendors are so like Microsoft and Mapr and Cloudera will offer their online courses for free because they want you to just get used to their technology. So then when you go and work, you say, "Oh, I know how to do that in whatever." You know, it just drives you down. You know, but that gives you an appreciation of what you can do with this technology and understand how you know AI is a very broad discipline like IoT. You know, machine learning I think is much more self-contained. It's, you know, there's a set of techniques where, you know, AI is about computer vision, is about knowledge representation, is about machine deep learning often. It's about you know, there's a whole bunch of techniques in there that make up AI, which, you know, so it's got very, very broad. But usually I'd say focus on an area and go into that. Because you can actually get in and then have a play around with it. You know, you know, you can do stuff on Raspberry Pis and all sorts these days to try and test this stuff out, or on your laptops. It's quite easy to get started. I mean, the best way is to get your hands on it and play with it. That's what I still do. Keeping it real, we call it in architecture. You know, don't want to get too far away that you just think it's in PowerPoint. You know, it all seems to work in PowerPoint. Yeah, look for practical stuff you can actually do. That would be my advice. The web's a great place. They're democratising it. You know, some of that education, at least getting you a starter to work out if you want to do it, and then you can actually look at some of the more. And if you want to go and get a master's, BT also sponsors people. Obviously, I did all my education through BT, so well, most of my after my A levels. So you know, it's quite good like that as well. So look for people who offer a learning that will allow you to develop and adapt your career throughout. You know, that's. Well, thank you. Thank you for inviting me today.
Thank you very much.